Hey everyone, and welcome to this explainer. I am absolutely thrilled to have you here today because honestly, we're tackling something that affects pretty much all of us every single day. We're diving into a really fascinating piece of research out of the Universiti Kuala Lumpur. They looked into how the design of your car's dashboard directly impacts your driving safety, your visual performance, and your cognitive bandwidth on the road. You know, this isn't just about making cars look futuristic and cool. It's about the very real, hard science of saving lives through experimental ergonomics.
So, let me ask you a quick question. Have you ever been driving down the highway in a brand new car, maybe a rental, and you get this sudden wave of panic just trying to, turn down the AC or check your fuel range? You're staring at this massive glowing iPad-like screen packed with colors and tiny text, and you're thinking, why does finding basic info feel like trying to solve a Rubik's Cube while operating heavy machinery? Well, it turns out that overwhelming feeling, it's not just in your head. It is a documented, highly measurable problem.
Okay, let's dive right into this. Here is our roadmap for today. First, the digital dashboard dilemma. Second, the ergonomics experiment. Third, a brightness breakthrough. Fourth, designing the Ergodash. And finally, number 5, the future of driving displays.
All right, kicking things off with Section 1, the digital dashboard dilemma, fast recognition versus visual distraction. It's kind of like night and day when you think about it. Back in the day, we had classic analog gauges. They did one thing, and they did it perfectly. The speedometer gave you your speed, the fuel gauge gave you your gas. They were physically separated, completely isolated, and took almost zero mental effort to read. But modern digital interfaces, man, they are absolutely packed with information. Navigation, tire pressure, efficiency scores, the whole shebang. But because all that rich data is crammed into one flat space, it creates a ton of visual clutter. You're not just glancing anymore, you're actively searching. And that heavy cognitive workload is exactly where things get dangerous. To really grasp what's at stake here, we need to talk about visual-manual interaction. Essentially, this is the physical and mental demand of taking your eyes off the road to mess with the device in the car. And why is this such a big deal? Well, to put it into perspective, if you're going 60 miles an hour, taking your eyes off the road for just 2 seconds means you've basically driven the length of an entire football field completely blind. Let that sink in. Every second you spend hunting for a tiny warning icon is a profoundly dangerous second.
Moving right along to Section 2, the ergonomics experiment, a dashboard stress test.
Now, what's really interesting about this study is that the researchers didn't just sit around theorizing. They set up a rigorous real-world laboratory stress test with licensed drivers. They used a 3x3 full factorial evaluation, so they took 3 dashboard types, analog, a fully digital one, and a hybrid, and tested them across 3 different screen brightness levels, low, medium, and high. That gives us 9 highly specific combinations to see exactly how human brains handle this info under pressure.
And they were incredibly precise about how they measured this. We're talking split-second visual performance broken down into 3 phases. First up, searching time, literally how long it takes your eye to find the data on the screen. Next, reading time, how long it takes your brain to process that number once you found it. And finally, total task completion time. They had drivers look for specific things like mileage and track their reaction times down to the microfraction of a second.
Which brings us to Section 3, a brightness breakthrough, the surprising hero of the data.
Okay, so going into this, you'd probably assume, actually I know I assumed, that the physical layout, like whether it was digital or analog, would be the main culprit for distraction. But the data threw a massive curveball. In statistics, when you see a p-value of less than 0.001, that is basically a flashing neon sign screaming, look at this. The dashboard type itself, not actually statistically significant. But display brightness? Display brightness was the absolute dominant factor. It significantly influenced every single time-based metric they tracked. Luminance literally stole the show.
Just look at these performance metrics for the high-brightness digital setup. This specific combo achieved the absolute best practical performance in the whole study. Searching time dropped down to just 4.722 seconds, and reading time was a wildly fast 2.626 seconds. Turns out, if you take a digital layout and crank up the brightness for high contrast and legibility, you give drivers the fastest possible access to what they need to know.
So the crucial point really comes down to this: total task completion time. With the low-brightness digital screen, drivers took almost 10 seconds, 9.918 seconds to be exact, to finish their visual tasks. But just by swapping to a high-brightness display, that time plummeted to 7.350 seconds. That is a massive 25.9% improvement.
When you're in a metal box hurtling down the highway, shaving 2.5 seconds off a driver's cognitive workload, that is, for sure, life-saving stuff.
That leads us perfectly into Section 4, Designing the Ergodash, Translating Data into Design.
The absolute best part is that the researchers didn't just publish a bunch of numbers and call it a day. They took all this hard data and built a real, tangible prototype called Ergodash. And let me tell you, it is like a deep breath for your brain. They used priority zoning, so life or death info is kept strictly together. They separated out the secondary stuff, so things you don't need immediately stay totally out of your way. They use super legible visual coding with large numerals and lots of clean white space. And of course, they applied that high-visibility digital profile based on the brightness breakthrough we just talked about.
And this brilliantly illustrates the hierarchy they created. Step 1 is the primary zone. Boom, right where your eyes naturally fall, reserved only for critical data, speed, warnings, and gear position. Step 2 covers the secondary zones. Things like fuel efficiency, trip data, and the clock are tucked neatly away from the center. It completely removes the visual clutter. You are never going to have to hunt for your speedometer through a jungle of media settings ever again.
Finally, Section 5, The Future of Driving Displays, a Modular Solution.
What makes the Ergodash concept a real game changer is how versatile it is. It's a completely modular, software-based layout. That means it can be seamlessly adapted for regular gas cars, hybrids, or full EVs. Since it's built on universal human ergonomics, car manufacturers can literally use this as a baseline. Instead of wasting time and money on endless prototype iterations, they can start right off the bat with a layout mathematically proven to reduce driver distraction.
I absolutely love this quote from the study because it totally hits the nail on the head. Ergodash demonstrates how experimental ergonomics can be converted into a usable dashboard design specification that supports faster information access and safer driver interaction. It's just the perfect bridge between strict academic lab testing and a real-world solution that actually makes our daily life safer.
So, I want to leave you with this final thought. Next time you hop into the driver's seat, just take a second to look critically at the screen in front of you. Is the really important stuff separated from the fluff? Is the contrast actually high enough for a split-second glance? Basically, does your car pass the Ergodash test? Because if you have to hunt around just to check your fuel range, well, maybe it's time automotive designers took a page out of this incredible research.